because
It's for education.
so up until now, we've done some problems where they gave us the domain, right?
Uh-huh.
But we also did some problems in the last chapter. Do you remember this? Y equals 2x plus 1. And you didn't have a domain. They didn't tell you what to pick for x. How did you know what to pick for x? Random ones. What are the possibilities? What could you pick for x? Anything, right? We said that we wanted to keep it kind of small because we were graphing it in some cases, but you could choose, if you wanted to choose 583, it would just be way down there, right? So what they're going to ask you for today is, what is the domain of this thing? Except they change it to a function. What's the domain of that function? And what they're asking you for, what are the possibilities for x? What could you pick for x? For most functions is, what did you just tell me you could pick for x? Because that's really what I'm asking when I ask you what is the domain of that function. What could you pick for x? X is the domain. And you just told me you could pick anything you wanted, right? That's true for most functions. The domain could be anything we want, but instead of saying anything we want, we say it like this. The domain for most functions is all real numbers. Because for most functions like this, the domain is all real numbers. Instead of writing out, if you don't want to write out all real numbers, that's what this means. Or if you wanted to write out, and I suppose we should say the domain equals, right? So the domain is all real numbers. However, there are two exceptions. What the heck? I used to be able to talk and write at the same time. Two exceptions. One of them, fractions. Since you graduated to algebra, something about a fraction that's not allowed. Do you remember? Zero what? Zero on the bottom. Not allowed, right? If I ask you what is, well, think about this. If I ask you what is 6 over 2, it's 3. And the way that you know it's right, if you multiply this times this, you get the number on top. But no matter what you put here, you can put any value you want. You cannot, there is no way that you can put a number here and multiply it by 0 and end up with 3. So 0 in the denominator is not allowed. You can't have 0 in the denominator. Denomination. There, now I think I got it. You cannot have 0 in the denominator. So if I ask you, what is the domain of this function? 1 over x plus 3. You have to throw out anything that makes the denominator 0. You can have almost any real number there, except anything that makes the denominator equal to 0. So what you do is set denominator equal to 0. Solve. That answer must be thrown out. So in general, and I know you probably could figure that out in your head, but there's probably going to be somewhere you can't figure it out in your head. You set the denominator equal to 0 and you solve it. So what do you get? That's the thing that's not allowed. That is the value that's not allowed. Because if I put x is -3, -3 plus 3 is 0. That's not allowed. My domain then is going to be all real numbers except what? -3. All real numbers except those that make the denominator equal to 0. And in this case, -3 makes it equal to 0. So my domain, all real numbers except -3. Does that make sense? Make sense? How about, I had some written in my book. How about this one? How about f of x 1 over x squared minus 4? Well, same thing. No matter what's in your denominator, you set it equal to 0. Set it equal to 0. Whatever's down there, set it equal to 0 and solve it. What are you going to do to solve this? Add 4 and then x squared equals 4. How do you get rid of a square? Square root, and I get x equals 2 or negative, right? Both of those. And both of those, if I put 2 here, 2 squared is 4. 4 take away 4 is 0. That's not allowed. If I put -2 there, -2 squared is 4. 4 take away 4 is 0. That's not allowed. So in this case, my domain, again, it's usually going to start off with all real numbers except what? All real numbers except 2 and -2. Is that making sense? Oh my God, the hot air is just blowing out of there. Anybody with questions so far? Anybody with questions so far? Anybody with questions so far? How about this? How about f of x equals 1 over x squared plus 9? Well, I'll give you a hint. Down here when we're all done, our domain is going to be all real numbers except something, except anything that makes a denominator equal to 0. Set that denominator equal to 0 again. There we go. I set it equal to 0, and now you're going to solve it. Are you ready to solve it? How do you solve it? So I get x squared equals negative 9, square root, square root. Square root of negative 9? Well, there is, but it's not a real number. So if I square root negative, no, there is none. It's not real. So remember, whatever we get for x, that's what we have to throw out. What do we have to throw out here? But it's not a real number anyway, right? This square root of negative 9, it doesn't come out to be a real number. So what real number do I have to throw out? Nothing. Because square root of negative 9 is not real anyway. Does that make sense? You don't have to throw anything out. So this one, the domain is just all real numbers. And by the way, first, does that make sense? Because you can't have the square root of a negative number, which right there, that leads me to number 2. What is number 2? What can't you have? What did you just tell me I can't have? Right, root. Can't have square root of a negative number. So if I have this, I better look at my examples written down so I can do one that actually, how about this? They have h of x. H of x equals square root of 2 minus x. And by the way, it's still going to be something like this. The domain equals all real numbers. Oops. But then we're going to have to specify, what about all real numbers? Well, all real numbers except 2 and negative 2. So what do we want here? In a square root, you're only allowed to have positives, right? So in other words, my 2 minus x has to be greater than 0, doesn't it? Or equal to. Could be equal to, because square root of 0 is 0. So the stuff underneath has to be greater than or equal to 0. And now you're going to solve that. How do you solve that? I would minus 2, so negative x greater than or equal to negative 2, multiply by -1 on both sides. This gives me x, this gives me 2, and you gotta flip your sign, right? So this means I have to choose x's that are less than or equal to 2. What's my domain? All real numbers where x is less than or equal to 2. That's my domain. I set it greater than or equal to 0, and then whatever I get, that's my domain. All real values where x is less than or equal to 2. Anything greater than 2 won't work because we're going to be subtracting something bigger, and that'll be a negative number. Does that make sense? Make sense? Caleb, make sense?
Yep.
Madison, you have questions? Are there any questions? Does anyone have a question? So I am on page 145 or so. Oh, thank you, you're the best. Here's what I have. We'll go 29 to 34. What did I say? Page 145. WE 29 to 58. 34. Oh, right. 34. And then 36, 38. Those are the ones we did yesterday. I think that's enough. I think that'll be enough by the time we get all those done. Maybe not, it might go quick. Oh, you know what else? I forgot to shut the video off. Does anybody have a question?